is a slight variation on the load path arch kixel steering system, which I demonstrated before. This time the kixels have got these stiffened sides. Now, the reason for this, as it's driving at the moment, you see how each kixel is slightly angled that way to the plane of the arch. So the whole thing is going to force this way. Set it upside down in the loft so that gravity is simulating the lift here. Now, I've got these steering bars on this time so that this line here, these two lines running along the thick load path line, so the control line, are going to pull the kixels aside. If I pull this bar, you see it's going to move that ring, which we're already at this side. So other side. Yeah, if I pull this line, it changes the whole form. Driving the other way. So whichever one you pull, the arch is going to pull away from it. You see there's a fair bit of tension in these as well in order to move these rings. Not half as much as would be if we were lifting properly in the load path. So a bit of experimenting. So the general layout here, you have two bars set. So you've got the back and the front edges. The front's slightly more open. So that was upside down in, and the other way up. Catching the wind, basically. Pinched at the back. There's the back, the front. And you've got a control bar here. And the control bar adjusts the kixels. That's pulled through towards the side at the moment. I've got a linkage at the moment. You'd probably have just, and that goes over the other control bar over there. You'd probably have, two folk working, somebody over that side, or two systems working. You wouldn't need to link those at all. You've got to make sure that you're not driving past endpoints. You're not getting caught at all. You'd want to limit on here, stopping where these control bars can, just how far they can travel. So you've got, again, on each point you've got marked out on the main line, that's the center point there, distance where the kixels are going to be set. Each kixel is mounted two sides. So that point here runs through this loop into that kixel, and right at the edge of it, there, through that loop, and it's up on there. And it connects. That's the far right-hand side one. If we look at, say, this one in the middle, so it's got a connection here, runs through to there. There's the kixel bar. This kixel is going through the loop out that way. So when this loop moves, it controls both. That one goes up, that one goes down. So we'll go back and tighten that from up here. So this kixel, is held out on that side, pinched to the line by that ring. So pinched to the load path by that ring. Kixel carries on this side. Here, this one. It's on the long side this time. Short side was to here, short side up to the load path, long after the connection to the load path. Here it's long side to the load path, short connection to the load path. It's tied on just up there, so we join in the red line there. So as the rings move relative to the load path points, the kixels change you look at the ring and what it does to those two bits there. That's the basics of it. Just like that. Easier with two people doing this. Can I pull that from there? Yeah, there we go. It's easy. You can do that from above. Okay. Now with this kixel model, these sticks run along the side of the kixel there. So because it's tilted that way, it's going to want to end up pushing off to the side, pulling the load path and the control lines off to this side, over this way. So as it pulls over this way, this is going to be the leading edge here of the kixel as it travels over this way. So yeah, it's going to be traveling this way. You want a nice, taut, tight, stiff leading edge. So I've stiffened that up with a stick in this case. And it lets you tie slightly outside the dimensions of the load pads. And that's going to have some advantages for stopping the whole thing tangling or inverting or getting in any mess. Also, it could be used as a furling as well. That's going to be a wee bit more complex. Where I've got these control lines, so you see this green and white and that red over there. Where I've got these, you can use one line instead. So it'll be a continuation of this center line. And the center line, I've got it running over the top here at the moment. It's very thin, hard to see. But you could have, instead of the one line up each side, so I've got a control line, main load path line, all the kixel mount lines. Same again over here. You've got the main load path line, control line, and kixel lines. You could have one control line running up the middle, running up there, and off of the one control line, going to the ring, a line going like that, there, and backwards that way as well. So you have one line and zigzags. Same that way. Sort of diamond shape coming off the single control line. But this way, with the two, you've got the chance to make adjustments. So you can put twist into the sails like that, or straighten them. So that's me pulling just on that top line. I can make them pull together. But if I adjust the control bar, you can put twist into the whole set. Now, obviously, a system like this, exactly as this model, is going to need very strong winds to fly. So, if you had very minimal sticks, I mean, these are broom handles, and that's heavy rope. This is just to hold the system down so that gravity is doing the job of wind lift in this model. If you had some very thin stiffening battens for these kixels, you could treat this as a reversible single skin. Just treat those kixels single skin reversible. Either, I don't know, you can maybe use a sort of power wing design, any of your good single skin designs that are right there. Instead, fly them side to side. Your overall arch dynamic, whether it's pinched at the back or whether you're really gathered at the back, or whether you want to stall it or reshape, skew it left or right, rechange the sort of scoop where it's holding to. So your overall arch dynamic can be changed up on these parts here. I've got them fixed to the wall at the moment, very much set in place so that I've got, say, x-axis and your z-axis control all listing. Again, on the back one, that's set in there. Hard in this light to see that. But yeah, should you be moving them instead, you'd have a lot more control over the overall formation of the arch. You know, like I say, whether it is scooped at the back or down at the back, whether you're stalling it or whether you're diving it, you know, whether you want that to steer and hit the ground, hit the ground that way, or fall backwards. That's where your main control for that would be tweaking that. What I've shown here is very much the single lifter surface, with the kixels steering themselves and being the full control and lift device of an arch kite. But if you add another, see this rope underneath there, if you add a separate lifting surface onto this load path, this one and the one at the back, so you've got another arch kite there, which would obviously in the flying model be above this set here. If you were to add that, then it means you can, so you got black cloth on there, it means you can either, there's a few things you can do. You can get rid of this, these load paths and have instead a curved beam to separate this, so a curved bent rod, and use the control lines to pinch a rope between there and drag either one side to the other and make this sort of cupped device curl like that or like that. Rather like an otter board or something like that, where you're pulling from one side of the wedge to the other. So you'd pull out this the side of the control line, and it would tilt that way against the lifting surface there. Pull the control line that way, and it would move across the rope that would be between the two front parts, and the rod that would stiffen this front connection would end up curling up this way, and your drive would go that way. So with that system, the control line works differently. You pull toward the side that you're getting pulled toward to, which makes end stops a bit easier to run if you're working a pump system. So that's the next model I'm going to build, is where you've got stiffening, a curved stiffening component stuck between there and there. And after building that model, again, where you've got this sheet on the bottom, or, well, controllable arch on the bottom, I'm going to be using a bunch of fins that'll control triangle sets and twist the back and bottom of those basically to steer the blades like that relative to the arch at the bottom. There'll be some bits up there going like this to steer left and right. And my hand's not very pretty still, but you know,